So it's going to be, again, integral of x squared to negative x cubed. So we first find the answer of this, which is the same because it's like the exponent never changes. So it's e to the negative x cubed. And we find the u, so u is going to be whatever is 0 that exponent. So it's u equals negative x cubed. We find the derivative, which equals squared. So we notice here the x squared is here because that's pretty much, yeah, so pretty much the x squares are on here, so not the negative thing. So we're going to bring it down because that's going to cancel it out. And then we add it to
Yeah, whatever this is, what is called, not confused.
The power of is you.
What is that? That's you.
What's that called?
What is that called?
This,
An exponent?
yeah, the exponent is you. Yeah.
There's like a third term.
How's it going, team?
This,
Yeah.
I'm wondering if we should, there's something has to be negative because this was on the bottom. It was also exponent.
So it was at the bottom. So yes, the 1 over 2 is going to have the negative, right, guys? Because when you bring it from the bottom to the top. Perfect. So, now notice how the x is actually already there, right? So what are we missing?
Just a 4.
So that means you're going to put 1/4, right? Okay, yeah, plus the one whole number, right?
Plus C, right?
No, not yet. So we got to fix this. So right here, put plus 2 over 2, because we have to add a whole number to it, right? So because if one of them is negative, you're actually going to end up subtracting. Perfect. So then that's what goes here. Now notice how there's also not a half, right? When you do it, when you look at the original, is there? Because that half is going to come down, right? Is there anything here? So then we also have to account for it, right? So we're going to multiply by 2. So it's not going to be 8, right?
Okay, 1 over 8.
And then plus C. Good job. What's going on?
Does that stay there?
So technically your U is the 2x over 3. Yeah. Can we like not write so in the corner? Okay. So it's going to be U is equal to 2x over 3, and the derivative of that is 2/3, right? Okay, perfect. So what is the antiderivative of cosine? Like what gave you cosine? Sine. So it's going to be sine 2x over 3, right? Now, when you take the derivative of this, do you notice how the 2/3 is going to come out? But do you see how there's no 2/3 up here? So we got to do the reciprocal, right? So we're going to do 3 over 2. That way, as soon as it comes out, we can cancel it out, right? Okay, so we have that going on. And now we're going to go from 0 to pi over 2, right? So remember, we're doing f v minus f a, like this. So that means we're going to have, not cosine. We're going to have 3 over 2 sine 2 times pi over 2. The 2's are going to cancel out, right? So then this, really all I have, what's sine pi? What's sine pi? Haha, just kidding. What's sine pi? Yeah, because remember, you're looking at unit circles, so pi is over here, right? So it's going to be negative 1, 0. So it's actually 0. So the 0, so that means the whole thing is 0, right? Now we're going to do the a part. So it's going to be 3 over 2 sine 2x over 3. And instead of writing x, what are we going to write? Come over here so you can see it. Instead of x, what are we going to write? 0, right? Okay, so what is sine 0? So that means in the unit circle is here, right? 1, 0. So sine is going to be also 0. So because this is 0, the answer is just 0. Okay? Does that kind of make sense? Yeah, so this one wasn't terrible, especially because sine and cosine are like the easiest ones, you know? How's it going, guys?
Scared.
Scared? You guys can do this. Okay. What's up?
So is this the U?
Like the top, would it be the U?
So
or
that's
would
the same
U?
problem that that group in the front is doing.
Oh, really? Okay.
Yeah, do you want to go hang out with them for a little bit?
David, let's go drink groups.
Yeah, go get some answers, okay? Looks like you guys are all stuck in the same problem, right? Okay, so this one shock to Natalie's group because they actually did this one. Hey, Yael, you're weird. All right, what are you guys doing? Math. Okay. Are you guys talking to each other? No, you gotta talk to each other, remember?
We subtract.
Yeah, so for that one, you're gonna have to write it twice.
Yeah, I'm assuming it cancels out. Right?
Yeah, so here, do you guys notice how you plug in the 1? So then you're gonna do it again, 1/3. Where'd you get the 1 from? Oh, I see. So now you're gonna do 0, right? And honestly, like, you can probably already tell.
It's gonna cancel out.
Yeah, so the whole thing is gonna cancel out. So all you're really looking at it is this, and you can do that with PEMDAS, right? Cool.
We're just gonna stick with this, huh?
Well, actually, I think this becomes 0 too. Because look, it's 1 minus 1. That's 0 times 1. So double check on that one because I think, like, I don't think it should end up in 0. So I think maybe you did something wrong. So go back and check your work, okay? How are we doing, guys?
Wait, what? Would it just be? Because this is the one that's like on the like, outside of everything that'd be a U. And since this never changes, you just put your 2x in. So it's 2x and then this is 1. No, but this is gonna be negative.
Calculator, guys? Not yet. Over e to the 2x, right? That's going to cancel out. This we're going to bring to the top. So it's going to be 4e to the 2x minus 1. Yeah? Yes. So
And
far,
that's
so
just
good?
a rule, right? To bring it to
No,
the
that's just algebra.
Okay, yeah.
That's
Okay.
just regular algebra, right? Okay. Remember, the hardest part about calculus is the algebra that you don't remember.
Yes.
Not the calculus concepts are actually pretty easy to
That's just the part that was confusing.
Yeah. Okay, so we have this going on, right? So this is supposed to be a negative. Okay, so let's look at this. Like, I know this is supposed to be negative x, right? This, so remember, e to the u is just e to the u, right? So in this scenario, my u is negative 2x and my derivative is negative 2, right? So we're going to have e to the negative 2x, right? Now, when I take a derivative, the negative 2 is going to come here, right?
Yeah,
But do you guys notice how in the original,
it's not there.
it's not there, right? There's no negative, so we have to account for the negative, right?
Okay.
Now, when I dropped the 2, this became a 4, so what was originally already there? A 2, right? So that should be my answer. Okay, so again, what's nice about integrals is that you guys can prove it, right? So we're going to prove it here. We're going to have negative 2 times negative 2 e to the negative 2x minus 1, right? That's going to become positive 4 e to the negative 2x minus 1, right? So you see how this is the original here?
Yeah.
Yeah, so that's kind of what that is, okay? So then now we know that this right here is our answer, right? Is that better?
Yes.
All right, sorry.